Well, it's not Tuesday, but we do have another teardown. This is a Headplay HMD, or head-mounted display. This was really big about like 3 or 4 years ago. It's one of those head-mounted displays that, you put on and look silly and you can watch video. I bought it because it supports 3D and I was interested in trying, video gaming in 3D. It was never very good. So it's been sitting around at my house for the last 4 years, basically in its case utterly untouched. Head-mounted displays are another one of those technologies that, it seems like it's a great idea, but it just never really made it because the resolution just isn't there. I mean, this was really one of the reasons I was really excited about this. Is this one is actually it's a whole SVGA. It's 800 by 600, which is actually pretty good. I mean, a lot of the cheap ones you see on eBay and so forth are, VGA 640 by 480, or most of them are actually HVGA, half VGA, 480 by 320, or even lower. So they're all pretty terrible. Here's the actual system. The way it works is it's got, the visor with the 2 actual displays on it, and there are the displays. And then it's got a controller, which is this, which basically, drives. It's got this big, I'm about 98% certain they're running LVDS up this cable. So it's got a big wide connector with a big wide ferrite on it. That's interesting. I bet they had noise issues in the production version. Then there's this controller, which is, that's what this small second section on this cable for, is for the buttons. So, typically, I bet 99% of the market for this is going to use it to watch, connect it to their computer or connect it to like a composite source. But of course, they had to have the option to play, it can play media off USB or compact flash cards, which should date it pretty effectively. It's got a lot of additional functions which are basically useless. As usual, they're too cheap to actually put separate connectors on it, so it's got one big PS2 style connector, like on a computer, that breaks out to this. I wonder if they actually save any money by doing this rather than just having, PS2 and so forth, or even why they even bothered passing audio through it. It's got a port for headphones, so it can do volume control internally, which is basically useless. This is actually very popular on the FPV crowd, the people who like to have a little wireless camera on their radio-controlled airplane. And so in that vein, one of the things it actually does is, if you pop the bottom off here, if I can remember how it comes apart, it's got this arrow on it, so I'm pretty sure this just slides. Oh, I remember now. So, push in there. So this has the option to actually run off a battery, so you can take it out in the field, and therefore, you basically plug it into your receiver, which is probably going to output composite, and you can, basically be flying your radio-controlled airplane first person, which is FPV, first person view. So, that's basically the entirety of the extant market for these things, as far as I can tell, is people who really desperately need an extremely portable display solution that's usable in extremely bright light situations. Basically people who fly radio-controlled airplanes. So the controller is pretty interesting. I've actually taken this apart once before, and I have some pictures that I think are actually already up on my website. But it's got a lot of stuff in it. It's actually extremely heavy, and it has, venting and all sorts of stuff. And there's a big chunk of aluminum in here because it gets quite warm. As you can probably tell, you get maybe 4 or 5 hours life off a giant battery, the size of a brick. It comes with a wall wart, and there's a nice fancy fitted case. And this is 12 volts at 1.25 amps. So, it's, that's a lot of power. That's about 15 or 16 watts. So, probably 10 watts of that is dissipated in the controller. So anyways, let's take a look in the controller. I actually think, if I remember correctly, So you can update the firmware, and I'm pretty sure that's what this is for. It's just like a little thumb drive branded thumb drive. It's a Headplay brand. So this is just held together with 3 Phillips screws. One thing I remember about taking this apart before is it's full of heatsink goo. Oops, there we go. And I think this is the warranty void if removed sticker. Nope. Of the 5 screws, and there's the 5th. And then, so you can see this is, it's got like a spray coating on it that's for EMI reduction. You know, both coming in and leaving the case. Actually, if we take a multimeter, so that's actually very conductive, you can see. You know, 2.73 ohms, and you know, so that's actually, you can see how conductive it is. So this is a very it's a metal doped paint of some sort. So here we can see how the case mounts in, and I'm pretty certain if I so there's more EMI. That's interesting. There's several layers of EMI reduction. So here is the controller. So as you can see, it's just extremely stuffed with stuff. There's the date, March 27th, 2007. So we've got all sorts of stuff. This is 1, 2, maybe even 3 DC to DCs. These could actually just be pi filters on the output to keep noise down. It has an FPGA in it. Here's a watch crystal. There's presumably an RTC on here somewhere. We've got 3 separate crystals. Let's see, that is 24.5075 or 24.5C75. One of these is probably timing, composite timing related, because it does again have a composite input. So that there's 12, which is presumably tied to the USB, and there's 27.0, so that's presumably tied to that. So this, and we have 2 big ICs. That's a micro 48LC2M32B2. That's probably RAM. You know, it's made by Micro. And over here we have another Micro part, I believe, if I'm remembering my chip logos properly, which I'm probably not. 46V16M16. That's probably more RAM of some sort. Lots and lots of tantalums, and you can probably tell just from looking at it that there's a big package here just based on the capacitor layout. And then there's another package here based on all of these vias. And I think, if I remember correctly, this has a big system on chip device, and then there's a Cyclone, Altera Cyclone right by the connector. But let me see if I can remember how I got this board out. Nope, never mind, it just falls out. You can see here's more of the really aggressive heat sinking. There's thermal goo everywhere. There's the grand single only button on the entire device. And there's some interesting cutouts for inductors. So this cover plate, I think, is just sitting on here by virtue of the adhesiveness of the thermal paste. Yeah. That is gooey. So you can tell that the joining between the 2 layers is not very aggressive, just by virtue of the fact that there's a lot of thermal paste in there. So if it was a really tightly clamped, it would squeeze most of the thermal paste out. how am I gonna put that down without getting thermal goo everywhere? Place it on the top of the case like that. So here you can see, right where I said there'd be a big package, there is a big package. And then there's the FPGA, presumably more RAM. That's interesting. There's a RAM IC here and a RAM IC there. This may be flash now that I think about it. It's interesting that it's covered by with some crap, I forget the name for it. Sorry, I'm having a dyslexic moment. So, you know, it's interesting it's covered by some tape. Headplay VMC, whatever that means. And you can see it's just oodles of devices. A lot of heat sinking. Let me go get some Q-tips and we will start taking some of the heat sink bits off. Here we are. It's interesting seeing what these part numbers are, so I'm going to leave as much of the paste in the edges as I can. So this is a Philips device. So here we have a Philips PNX0192E 300 megahertz. So presumably that's the core frequency. Let's see if I can see what this interesting logo down here. So that I'm pretty sure is like an integrated, like an entertainment device. Can't make out what that says. So then I'm pretty sure this is just an FPGA, and I think this is also used as like a display buffer or a line driver. Because one of the things you can do with a lot of the Altera devices is they have LVDS capable outputs. So I'm pretty sure about half of what they're doing with this is just using it as a line driver to drive the cable. Let's see how good my memory is. It's been about 2 years since I took this apart. If it's a cyclone, so I haven't totally lost touch. It's in fact a cyclone too. So here we have a Altera Cyclone 2 EP2C8 F256C7N. So that's not the bottom of the barrel speed grade, that's C8. It's a 256 ball BGA package. It's a Cyclone 2, which is what the 2 in the EP2 is, and C8 means it has 8,000 logic elements or macros. Well, they're slightly different. Xilinx parts are macro cells, and Altera parts are rated in logic elements, and I think a logic element is like equivalent to several macro cells. Let's see, I bet this is the same RAM IC as the other one. The one on the other side, I mean. It's definitely a micro part, if I got my part numbers correct, which apparently I'm managing to fail to do on a regular basis these days. So that is a 46V16M16. That's also a 46V16M16. So those are the same parts. It's interesting they only heat synced one side. That makes me think the heat sinking on that is a bit superfluous, or they're just trying to heat sink one through the other one, which is just stupid. Lastly, we have this device here, which I would bet is related to the VGA port. Could be related to the battery, but I bet that's what a lot of this stuff does. So one thing you can see is there's a whole series of DC to DCs here, which are probably for core voltage for this and for the Cyclone, because they all take an interesting assortment of voltages. There's some RGB LEDs that light up the buttons. And I would assume these are power MOSFETs. Just let's see what the pinout looks like. Yeah, considering a bunch of two of the pins here and two of the pins here are strapped together, Those are power switchers of some sort, and I bet this is a DC to DC controller IC of some sort. Let's see if I can make out the part number. Is that Intersil? Looks like it. ISC 62 something. (6232CAZ), I think. But considering how some of these really chunky traces are running right to these pins, this has to be heavily involved. It's really interesting. Look at all of this. Really, actually rather beautiful. You know, there's an enormous amount of care taken, I think, from looking at it, with a lot of the grounding here. There's 3 test points on the same big power trace. I mean, it looks like a lot of work. Here's another Intersil, ISL 6253HRZ, LX245B. Here's an interesting part. NXP devices of some sort. Come on, focus already. LVCH16245A. I bet they're buffers of some sort just from the way they're placed and all of those resistor arrays there. So there is... what is that? Camera's apparently overheating again. SAA7113H CS7988.00 SP430 F1232. A lot of interesting packages here. It's all BGA too, which tells you something. I think that's an Intel part 256P30T A7057525. Over here we have more power supply of some sort. One second, I'm going to try and put a macro lens on this camera. Okay. Let's see if this is any better. So there's the main application processor, PNX019. So, one second. This is manual focus. There we go. There's the ISL 6232CAZ, ISL 6253HRZ, SP430 F1232, SAA7113H CS7988.0, 256P30T A7057525. And there are those, I think it's an RGB LED. It's certainly got 4 leads. Lots of buffers, inductors. HJRA5228, I think. Heatsink go everywhere. They kind of made a spectacular mess of the heatsink paste. Put way more on than I think they should have. One thing that's really interesting you can see here is 225M, 39M. I bet these are like milliohm resistors, I would guess. There's a 0 ohm shunt. That's rather intriguing. There's a big diode. Let me... sorry, this lens is manual. Let me see if I can get the... this is another Phillips part. So here we... and it overheated again. And I'll try that again now that it seems to have had enough, finished its nervous breakdown. So here's the part. I just got heatsink paste on my thumb. So here's the part by the VGA. This is a TDA9955HL S60945.1 Z lowercase tg07061. Interesting part numbers. Lots of resistor arrays. This is quite the board. This is a part, and here's ISP 17G1ET. From its position, I'd guess, because the USB connectors are right here and right here, I guess that's involved in adding USB host facilities to this big Philips system on chip. It's an unstuffed part. Here's a crystal, 20.0. That's a 20 megahertz crystal right proximate to the FPGA. Lots of little parts. Look at that little tiny diode. I bet that's a protection package for the USB. That, and there's another one right there by the other USB interface. There's the composite inputs, is that row of pins, and I bet they're... And look at it, that goes to this, which is the SAA7113H. So that could be involved in audio, because again, this thing does pass audio through the circuit board. Oops, where's focus? There it is. It's just oodles of parts and lots of little fine traces. So much on here. And there are those big power devices. Let me hit those with the Q-tip. International rectifier P703H, B3G6, F7303. I'm going to assume they're the same, but they're labeled Q3, and which is certainly rather illuminating. Yeah, that one's Q4. Sorry about the narrow depth of field. The Q3 and Q4, so those are definitely power transistors. Man, that's interesting. Look at that. They have... So if you look right there, they've got two separate via sizes connecting that trace to the other layer. This board's really interesting. Test point. On semi-diode. Whatever that is. More tense. Interesting, they seem to have, a lot of the ground planes have curved profiles. Presumably that's programming of some sort, J3 and J4, though I don't see any divots from like a bed of nails programmer. It's interesting looking at all these vias they're using to stitch these layers together. What do we have here? So that is... I'm not familiar with that logo. There is AKQ T1 space 71 M860W. A couple little transistors. Let's see, let's rotate that around. So that part is a 4341CZZ XNG0634. That, oh look at that. That's an Atmel, I bet that's an EEPROM. 24C16, yep. I think that's an I2C EEPROM. I don't know what that's for. One of the other things you can see is, I wonder if that trace there is a differential pair. Kind of looks it. I bet if we go over here. Okay, so if you look here, see all of those traces coming out of the FPGA that are going into two rows of vias? Those have to be connecting to this package here. So presumably this is RAM for the FPGA. And then here you can see RRR, so these are presumably LVDS pairs. 2, 3, 4, 5 pairs of LVDS. And then all of these, so these are all the breakout vias for the FPGA. And you've got electrolytics and lots of ceramic bypass. I wonder if that crystal's tied into the FPGA somehow. Here's tantalums, this is all the bypass. Let me zoom in a little bit. That's all bypass. Look at some of the delicate, look at how they're numbering. That's really actually quite nice. They have these nice little lines running to the capacitors showing their part numbers. They've also got the plus symbols on these two tanks overlapping, which is a little sloppy. Over here they've made them overlap perfectly so that they're just both positive in that direction, which is a lot nicer. They've also got the plus symbol overlapping with some of the lettering. It's a little sloppy, but it's not a big deal really, because you can still figure out what it's doing, and there, overheated again. My apologies, my camera is apparently in nervous breakdown mode this evening. So what I'm going to do now is I'm just going to kind of try and scoop up some of this thermal paste that they've gobbed everywhere and just dab it onto the couple of the parts where I've pushed all the thermal paste off of it. So, man, they have put a lot of thermal paste on here. Unfortunately, the white thermal paste is, I think it's silicon based, I don't remember. But it's non-conductive, so it doesn't matter if it kind of winds up oozing everywhere. But it does, it just looks terrible, and it doesn't actually help the performance having it everywhere or anything. So it's just sloppy. It's, you know, it's bad design. Or, well, this isn't design, this is manufacturing, so it's bad. It's fortunately not, you know, a big deal, but really? I mean, did you need to use that much of this stuff? I mean, some of this stuff I'm dubious about whether it needs it at all. Like that RAM IC. Especially seeing as the identical RAM IC on the other side of the board is not heat sunk. It just seems kind of superfluous. I mean, I'll maintain... I mean, it gets warm, but... Or I wonder which, you know, if they did any sort of actual energy budgeting to determine where the heat's coming from, because I doubt it's the RAM. You know. Anyways. So I will carefully place that back on there. Oops. This whole thing is very tightly fitted. It's got gaskets and all sorts of bizarre junk all over it. Oops, there it goes. How do you kind of snaps down on there, I think. One of the things you can see is that there's a big layer of metal down in here. Apparently there's with a plastic cover on it, which I'm sure helps enormously with heat dissipation. You can kind of see there's where the button pokes through in the center. I mean, at least one of the nice things is that means that these screws are going into metal, so the mechanism for holding it together is very strong. Because you've got just metal screws going into metal. But, I mean, still, it seems kind of ridiculous. Just try to hold this apparatus. No, I think I'll put it in 2 sections then. Like that. So then these screws also provide clamping force for the heat sinks. So here's more of the EMI filter, and there's some nice little pads to keep it from rattling. And finally this section goes on. It all sits together. Nice and tight, and you don't have to worry about thermal issues anymore. Well, I do have to worry about the fact that apparently I have heatsink greases everywhere. So anyways, there's the control box. And then over here, that snaps in there. And there you go. It's very solid. I mean, it's a very nicely engineered piece of kit. Moving on. So here's the display unit. I know that this uses an LCOS, or liquid crystal on silicon display, which is interesting. It's also got like this fancy, you know, Velcro-y, or well, not Velcro, ratchety mechanism. Kind of see how that fits inside of there. Actually, so I believe I can probably take the system entirely apart. So if we look down in here, I mean, there's not much in there really. I mean, the whole visor is just there for cutesiness, I think. I might actually cut the visor off because it doesn't provide much. I mean, this rigid plastic assembly is everything that's really needed. I misplaced all my hex wrenches because I'm apparently totally a space case. 1 second. Alright, I found my socket set and got stuck under an LCD. So I think I'm just going to say to hell with the visor because it's there just... One of the things they billed this as when they sold it is, you know, they hired some fancy pants industrial designer to make it look stylish because, you know, that's a relative, you know, the whole standing around out in public, you know, talking to yourself while wearing a computer monitor, you know, those are the people who care about, you know, looking stylish. Anyways, I've never really given a crap about it, but whatever. So it's got an Allen wrench or hex wrench socket in there from the look of it. Not sure if this thing is built to metric or standard, so we'll try SAE first, and bingo. Rather tight. Oh, look at that. So there's the so there you can see how the ratchet mechanism worked. It's got a corrugated surface right here. So we'll focus. So that's corrugated, and then if you look here, there is a little spring and a ball bearing that sat in it. So that rode against the edge of that metal section. And actually, now that I think about it, I am going about this wrong. I should be taking it apart. I should, instead of removing this section, I should remove those two smaller sections. It's interesting that there's actually, it appears there's two metal washers with an O-ring between them, which presumably maintains a certain level of tension. So that's kind of like a spring for the slider, so it can't move too freely. So now that I look at it again, I should be taking... I took the wrong screw out. I should take these two out, which are one size smaller. But it certainly does seem to be SAE, rather. No, maybe not. Okay, let's try metric. Oh, I guess it is metric. Oops. Well, these screws sure feel like they're going into plastic where they have thread locker. So there's one. Put away. Kind of remarkable. Any situation where I'd want to use this, I'd probably have my laptop along, and in which case I'd rather just use the laptop display. So there's the headband, free from the rest of the apparatus. And this thing, I'm not too sure how it's held together, because I see two holes here, but they just seem to be dead. They don't seem to go anywhere. Oh wait, no, my bad. There is in fact a Phillips screw way down in there. Just close up my Allen wrench set. If I don't keep these organized in their little snap together set, I will confuse the standard and the metric. So down here you can see it's got interpupillary distance adjusters, which are, they just move the little screens back and forth. And then you have focus, which moves elements around inside the lens assembly. And then there's a cover glass, which is there to pick up fingerprints apparently. There we go. Oh wow, those are really loose. I didn't even need to use the screwdriver handle on it. There's one. Oh, there's the other. So let's see now. Well, that, what does that free? Oh. Okay, so there's this. My, they do like sticky tape, don't they? That wasn't sticky tape, my bad. That's like white glue from the look of it. With a, I would assume that's a warranty void if removed sticker. And then we have a whole bunch more screw holes that are very deep. I think, yeah, that's a little big actually. Go. I bought a couple jeweler's screwdriver sets recently. I figured I bought them, and apparently that was a wise purchase. I always buy them and then I lose them or they get lost in it. I'm just chronically terrible at keeping track of things, I think. Ugh. That. There's that. It's interesting to note that this isn't completely symmetric. There's a screw over here, but there isn't one, a corresponding screw on this side. They come loose. That should be the last screw. It's interesting, there's white stuff on these screws. I wonder... Oh Christ, is that more silicone heatsink paste? Sure feels like it. I'm kind of afraid of what I'm going to find in here if there's heatsink goo on the screw threads. That's slightly terrifying, actually. So I think that holds... I think it splits along that crack, yep. Here's the warranty void sticker. Well, that's intriguing. So one of the things about this is that it supports stereo video, which is one of the things that made me interested, but it also, when you put it in stereo mode, the display's dim, and it appears the reason that that happens is because it only has one display. So you can see now that Oh, let's see, yeah. So that's how they move like that, and then how does the other one? Oh. So that is the focus. Oh, well, that's interesting. Look at that interesting assembly. So there's like a... I'm not sure what some of this stuff does, but it appears that the focus sliders somehow adjust this mirror, and I think the optical path comes in here, bounces off this partially silvered mirror, reflects off here, and then passes through the partially silvered mirror and enters that. It's actually, the whole mechanism is very strange. I mean, I would think they'd just have a mirror like this so that you just look straight into the display, but they've got, I mean, it looks like they're trying to fold the optical path so that the effective distance between the lens here and the objective for the eyepiece is further. And then the advantage of that is that if this is at a fixed distance, that means that the overall, by moving these two in conjunction, the overall optical path stays the same when the interpupillary distance changes, because you can see that it has to travel further back. But it's a very odd optical system. But anyways, it seems like everything of interest is in the center. So that shall be where I shall go next. It seems like the cable runs under some of this stuff. Anyways, I see 4 screws that hold that in, and this appears to be cover tape. You can start to see there's some Captain, that's what it is, it's Captain tape covering that. It's got a big barcode. Apparently this is Rev A.01. So I bought this just about when it came out, so I think this is probably the first version. It's interesting, I wonder if this is to keep light out. They've only put 3 screws in it too, there's not one in this corner. Anyways, these screws appear to be pretty heavily glued down. There's like goo around them. I don't know if you can see it, but there's definitely something around them. Hopefully this thing will still work when I put it back together. And I wouldn't be too crushed to lose it, but it was expensive, and I always feel like I'm going to have a project that's going to need something like this right around the corner, and then of course never do, but I never said it was a rational worry. So that appears to be the display assembly, and look at all of that. Look at all those discretes. This thing is very strange. Oh my! So look at this. We have springs. So these screws are actually a leveling mechanism. So yeah, I think I might have just tanked it a little bit. I wonder where the third spring went. So I think that you have to align everything in here very precisely. I mean, I've taken apart a DSLR before to the point where I actually had to recalibrate the focus mechanism, and it looks kind of like that. Well, that's interesting. I don't think there's a spring on this third one. I think it only had 2 springs. I wonder how that worked. So anyways, this is a direct wire to board assembly. There is not even a connector there. Man, they were lazy. That's really interesting. But can I get this cable free somehow? So what holds this whole thing in here? I don't think there's any way I'm going to free that cable up. means I have to kind of work with it dangling, I guess. So this whole assembly is kind of intriguing. It's got like, it's all a flat flex, a flex rigid thing, but it's like wrapped in on itself in a rather contorted manner. Let's see if I can pop this linear slide rod out. I think that's what's holding all of this optical stuff in there. Yeah. Why was pulling it back? Oh, I see. Oy. Something just fell off. Up. Oh, there's more springs. Oh no, that was the old spring. So here we can see. So there's the screw mechanism that moves those two in conjunction. I think So this is all, it feels like fiber reinforced plastic. But there you can kind of see how they've got a rack and pinion assembly that moves in counterpoint. If I look at this side, I think, yeah, I'm pretty sure it's still centered enough. So that screw came off there, and it looks like there's heatsink grease on all of these screws. I have no fucking clue why, but it does mean that I get it everywhere. So anyways, excuse me for a second, changing batteries. Sorry, I ran the battery on my camera flat. I'm shooting with a like an SLR digital camera type. It's a Sony NEX-5N, and it does video rather nicely, but it doesn't do it for very long. So here we can see that we have the two optical assemblies, and one of the things that's actually kind of interesting is you can actually see through it a little bit. So it's all partially silvered mirrors from the look of it. This looks like it's some sort of weird mechanism for them to I mean, be cheap and use only one actual LCOS, liquid crystalline silicon screen for two eyepieces, which is kind of obnoxious. I guess they're just cheap. Captain tape and lots of interesting. I mean, look at all of those discretes. I mean, kind of an interesting signal path. I wonder where the actual, I think the display is right in here. There's a lot of tape. I would assume this tape is kind of just trying to keep spurious. Well, I'm not sure. I mean, I would think it would be to keep spurious light out of the signal path, or the optical path. But I can't really, I mean, it's in a black case. How is light going to get in there? That's interesting. There's the back of a mirror. It's held in with glue. Oh, hello. So, get that down. So there you can kind of see how there's two partially silvered mirrors in there. I think they're partially silvered. It might also be reflecting somewhere further down the path. So there's the optical path comes in here, hits that mirror, and goes that way. Reflects off. And there it goes again. Rather monotonous. So it reflects off of this mirror here, which is glued in, and then enters something down here. So let me pop these two little latches up. We shall see what's inside. Oh wow. So, oh boy, I'm not too sure how that worked. So it appears I just hemorrhaged a prism. So that sat right there. And then over here, so this is some sort of Well, it's on silicon, so that the LCD is actually, it's reflective. It's not transparent like most LCDs, which are backlit. So this has to be frontlit. So I think we have two backlights, and they reflect off it at different angles. Because these are little LEDs here. And in fact, I bet these are RGB LEDs, and they are. So it's an 800 by 600 display, and it actually switches the colors. So then this has got to be like the actual display has to be down in there, and then this is like a backlight diffuser of some sort. I'm getting dust in the optical pass. So this just is a backlight deflector, and you can see it's metallized on this side for reflectivity. And then this sits on there, I think. Okay, yeah. So these LEDs actually sit into that, and then that shines into that side, and it looks like it reflects off that and enters the optical path. So that's rather intriguing. So this just holds the backlight on. My camera is going to overheat yet again. See if I can get this to snap back together. There we go. So it looks like a lot of this is held together by those two screws there. Turn the exposure down a little bit. We're looking at a black object. Good. There's one. And I think I have to have the backlight off just because the case clamps get in the way. Let me take that off. Even this is a really rather contorted optical assembly. It's got mirrors. Look at that, it doesn't just have a mirror on it. It's got a corrugated mirror. Presumably for taking a point source and kind of diffusing it a little bit. You know, here's a big, it's plastic, but it's a big complicated prism shape with interesting edges. You know, you've got, it's just a very involved mechanism. I think it would have been cheaper to just put one frickin' LCOS display on each eye. So I think big heavy traces. So all of these discretes must be backlight switching of some sort. Presumably you've got big power traces running to it. And this is a 2-layer flex. So presumably that's all modulation and all sorts of interesting jazz. That's interesting. Oh, so look, I think here we can see the actual, I would assume the actual LCOS display is that bright thing right in there. So this is, there's a big, that's actually glass. As opposed to a lot of the stuff which is probably like polycarb or something like that. And it looks like these two screws here are what retain it. So I think I might have to take this whole assembly even further apart. Because I really want to get in there to the point where I can like look at the display. Even if I'm not actually going to really do anything with it. I might try and play a video with it on, that'd be interesting. So it looks like I'm going to have to take off these lenses. Should probably have put paper down. It's interesting there, it's only 2 screws on each side. You can see the partially silvered mirror, and there's actually a round aperture mask down there. So now let's take a look at, take the other one off, because it seems like these are partially holding the part of the optical path on. In fact, I think I only need to take this corner screw out. I think I can leave the actual optics on there. So I think I just need to go over here. It's a lot of wires. Nope, I think I do have to take them both off. Maybe only one, now that I think about it, actually. Nope. Nope, yeah, I do only need to take that one out. So I think, oh, I'm losing lenses. This thing is just so intricate. So there's, if you can see there, the two entries, and what is it looking at? Excuse me. So you can see through there, but you've got these two apertures with what looks like a diffusion filter over them, actually. I mean, and if we flip over here, you can see the other side of them. But why would they put like a plastic screen on them? I wonder if they're doing some sort of polarization jazz. That might be a polarization filter now that I think about it. And if we go here, we look down in there, that should be the actual LCOS screen. So I would assume that the reflectivity of that modulates based on the input signal. So what I'm going to do now is I'm going to power the whole affair on. So, grab the brick. And then this goes like that, and this connector plugs in there. Let's turn it on. I think it's on, and yep. So we can see the backlights are lit up. And now look at that. See the color banding? So they are in. Anyways, I'm pretty sure it's running right now, and you can actually see, if you look at the banding of the coloring, I'm pretty certain the LEDs are in fact pulse width modulating in the various colors, but you can't really see anything on the actual LCOS device. And I'm guessing that's because, like most LCDs, I bet this one doesn't actually modulate overall reflectivity, it just changes the polarization. Actually, now that I think about it, hold on a second, I think I have a polarizer. Fortunately, I have some photographic polarizers. I want a linear polarizer. So, see anything going on. So I mean, one of the things I can do is I can look at whether, so that does tell me that these are polarized. You see they go opaque and they go transparent. So I wonder if there's another source of polarization, because a lot of what the LCDs do is they'll twist the polarization of light passing through or reflecting off them, but I don't see where it could be polarizing. So I'm not actually sure how it works because I can't see anything on the screen. But let me just start putting it back together, see if anything comes to me. It's a lens that's curved on both sides and to a slightly different extent. I'm not sure which way it goes. Q-tips. No, I didn't. Seems to be much holding that in. This thing uses a lot of partially silvered mirrors. So is this in backwards? Why is it making that noise? I think I do have it in upside down because it sounds like the two, that and this other convex mirror, whoops, are making contact and clacking together. Yeah, now they are just clearing. So I think not too sure how that's actually held in there. Aside from the fact that I think it has to be assembled this way because the lens kind of sits into that. There it goes. The whole thing is kind of a pain in the ass to put together. In a second I'm going to have a, once I get it back together, I'm going to poke around for the LED drive signals on a scope. Oops. Screws are escaping. Probably a function of 240 Hertz. You've got 60 Hertz update 3 times a second for 3 different, well, 120 Hertz actually. It goes at 60 Hertz. Maybe it may update 120 Hertz and then each color. So finally, that sits on there, and then the LEDs. So there you can kind of see how these basically function as diffusers. Oops. And finally, this metal bracket holds the whole thing together, keeps the LEDs aligned. And the prism has fallen out. There we go. So. Let's see if I can't see something at all. Okay, it's booting. Let's see if you can see that. So there's the, you can see in the display it's doing something. So there's just like the steady state, kind of the sitting there doing nothing. Actually, now that I can get there, kind of want to take this off and see if I can see in there. So I should. Nah, it's just reflective. Yeah, I'm not sure how it works. Because I mean, I would assume it's doing something clever. But I bet it's heavily involved with polarization, just because most LCDs are functionally, they operate on the polarization of the light they're transmitting or reflecting. And also the fact that you can't see anything when you look at it normally, you know, would make me assume it's polarization based, simply because there's not much else you can do that wouldn't produce a visible modulation of light intensity. So if I go like that, yeah, it's still there. It's just sitting at the home screen. Oops. You stay shut, and there it goes. So, I've just got my 7904, which is probably one of the best purely analog oscilloscopes ever made. Some of the late Tektronix, back when they really knew what they were doing. Let's get on the right vert. Focus is all mangled. Intensity down. Oops. Let's see if I can find a ground on here. I can always clip to the capacitor, but that's, I'll just use the shield because that's convenient. I would assume it's grounded. Let's take a look. Let's go to 1X. DC, hello. That is 12 volts. Wow. Alright, so let me see if I can do something clever. Disconnect the external monitor from my camera. Let's see if I can unclip it from the tripod I have hanging from the wall. So, here's my scope. And if I go on the LED terminals, you can probably tell it's 5 volts per div. So let's turn the time base down a little bit. So it looks like it's going open collector and then just drifting down. You can see it's 5 volts per div, so that's 10 volts. That one's 12. That one's about 8. So it's a lot of... They're putting 12 volts across this LED. I wonder if they're overdriving it, or maybe they're driving the two in series. See if I can find any of the drive signals for the actual... Oh wow, this thing is getting warm. Let's see, they're all SOT23 devices. Okay, so there's one base drive. That's interesting. So I wonder if that's the input voltage. But anyways, you can see we are at 1... Let's see, where was that nice signal? So we're at 1 millisecond per div, and it is about 2.5 millisecond rep rate. So I don't... So that, I mean, it's cycling pretty rapidly. Though I think each one of those is possibly per color. Vaguely interesting. Anyways, this is a it's a Tektronix 7902, and I've got a couple of the really nice plugins, 500 megahertz. Probably the 7904 and the 7904A are some of the nicest fully analog oscilloscopes basically ever made, I would say. You know, they're really wonderful. They've got just oodles of plugins. I've got a bunch of them. They're fully repairable. Everything about them, you know, every single part on the entire scope is detailed in detail. You know, I mean, they're complete schematics available. They're utterly repairable. I mean, if you don't need a digital scope, it is without a doubt probably one of the best tools on the market. And one of the really nice things is you can get them for peanuts because people don't know what they have anymore. Oops, wrong way. So anyways, one of the things that I did notice is that this whole affair gets quite toasty. Let's see, here's the backside of the LCOS display. Oops. This whole flat assembly held together with some goo, as they seem to really like to do. This is like vinyl tape, so you can actually see here's the chip on the back. So there's an IC and a crystal, and here's this tape. So here are the signal lines coming in, and that is a MSP430. Really? MSP430F1222. That may be, in fact, an entire microprocessor, because the MSP430 is a micro, and that's an 8 megahertz crystal on it. So that's a TI device if it is indeed an MSP430. TI73WD, and it looks like it's TI. So then there's just a couple of really big ceramic caps. You can see the color modulating. It's beating against the camera scan rate. This whole assembly is really amazing, kind of. And if you look down into the display, it appears it's gone to sleep. Now it's booting again. Let's see if you can make this out. So there's the display. It's a little progress bar on the top. And then there's kind of the static display, and I don't know if you can see it, but you can move around the menus with the remote. And if you have like media on an external SD card or something, it'll play that. You can select the input and all sorts of other crap. It's really rather fancy. Anyways, so let me grab a Q-tip, just try and get any fingerprints I put on the display off. Because I'm pretty certain I left a number of them. So then this bit of tape covers up that whole big gaping hole in the optical assembly. I'm not sure why, again, this whole thing is in basically a sealed plastic box. I'm not sure why they're worried about light leakage into it, but I mean the Captain tape I can understand just as like, I guess I don't even know why they need to bother with the Captain tape, because it's not like they're going to get fingers in here, except when, you know, yahoos like me decide they want to take it apart and see how it works. So the whole thing strikes me as a little bit odd. But anyways, so this assembly, fuck, I keep grabbing it in a way that results in me rubbing my fat fingers all over the LCD. So that sits in that little section. And this cable, let's wrap the cable first. Cable goes like that. This whole assembly sits down on those two screws. I think that's the right screw for that. I have two screws of identical lengths with slightly different threads. That's terrible. These screws are slightly smaller in diameter. That's better. Let's see it more clearly. Still don't understand why there's silicone thermal paste on all of these screws, but it seems to be the least of my worries at this point. Bother. So I can kind of get it to stick on that screwdriver a little bit. You know what? I have a big magnet. Let's do it that way. Wire cutters to the rescue, I guess. This tape has come a little loose. Just kind of tuck it down in there, along with all of the wires. And seat the cable. And there's a big strain relief on the end there. Fold it. last screw, which is that one. This needs to go in there. Excellent. So now let me see if I can see something related to let's see if I can make out. Hope it appears I'm holding it upside down. Alright, well, let's see if I can snap the other eyepiece in. So this one end of the linear bearing rod goes like that, and the other end sits down in there. And then this is just held in with a snap in the plastic, like that. And it appears I have lost the detent, which I didn't even notice was there when I took it apart. So there's the detent. It's that little ball, and it rides in a groove on the bottom of this thing. So it pushes against that. So why isn't it ratcheting anymore? Just decided it wanted to work. That's rather interesting. So let me see. It appears it's still functional. Oh, I think I see what's going on. So I think these screws adjust the parallax. Because otherwise, right now, when I look in there, one display looks kind of crooked compared to the other. Yep. So I can see one eye move relative to the other. Oops. So I bet then the last screw will probably adjust the relative angle. It's interesting how effective your mind is at, I mean, even if I can visibly see that they're not aligned, you know, you kind of, your visual system toggles between, you know, seeing them separately and joining them up, even though there's a discontinuity between the two. So your mind is remarkably adept at lining the two up, even though they're not the same. Seems to have tuned them together. So it seems like I've got it more or less homed again. So now I want to push these all the way in, and same with the focus. And now I just have to take a couple more Q-tips and just do a once over on all of the optics internally. Anything I could have touched in any event. Hit it with some canned air just to make sure there's nothing going on. Make sure those are all the way in. Make sure those are all the way forward. Oh, whoops. This cord keeps coming loose. Just to kind of sit in there. Doesn't seem like it's engaged. So I think, oh, that's cute. It says it's mine right there. What the hell? They are trying far too hard. So I think these need to be all the way out. With a diopter adjustment of 0. There it goes. All right. Seems to be lined up again. So there we go. So there is the teardown and subsequent reassembly of a rather silly piece of hardware, a Headplay head-mounted display. It's interesting. I was under the impression it used only a single LCOS device, you know, for both eyes. But it's very neat to see how it actually works internally. You know, and I guess that there were probably volume issues or something on the actual display, so they wanted to split one between two eyes. Because I imagine it would make the optical design, you know, inordinately simpler to use only, you know, to use two displays. You know, and in fact, most of the cheap little, you know, cheapo LCD head mount. Sorry, it just skipped itself. I think it ran out of, it's the 30-minute limit. So I'd imagine that the cheaper, or it's interesting that, you know, maybe because of the high resolution, but I'm fairly confident that, you know, I've seen teardowns of some of the less expensive head-mounted displays, and they do use only a single, or they use dual, sorry, they use dual LCD modules, for one per each eye. So I wonder what motivated them to use, you know, two, you know, or to use a single one and deal with all of the complex optics. Like, I wonder if there was volume issues with producing enough of them for, you know, having, you know, oops, sorry, it seems to, you know, if there are volume issues producing enough that you can run one per eye instead of one with a complex system to split it. You know, especially in a situation where you need to support stereo, where you need to be able to toggle each eye on and off, which this one claims to be able to do. Anyways, let's see. So there's kind of the, let's see if I can get a view into the system. So it's, you know, you've got a menu and a media source, and you can kind of see, you can change it, and it supports all sorts of jazz. You know, you have, I'm not sure what that is. I don't have manual focus right now, so focus is confusing. But yeah, it supports, right, well, let's, oops, user settings, language, you know, source, system settings. You can update the image Wireless settings. Oh, it supports a wireless device, I think. Diagnostics.